So for reinforcement learning, we're looking at the value iteration algorithm, the Q-learning, and the SAR-SA algorithms. So value iteration is found in this Python file. To operate it, you can change the file name and change this track name to reflect what file you're interested in, and then change the variable names or variable values to what you would like. So if we run this, we're going to choose crash scenario 1 that starts from the nearest point on the track, and we're going to start at 5 for the initial number of training iterations. We'll let it run. And we can see that it is trying out the different pathways. So X is our car moving, and you can see it producing an ASCII output, so you can track the different trials as it's training the model for how to go around the racetrack. So you saw it run through the training iterations of 5. You saw at some points where it did finish, because you can see the X at the finish line, and you saw multiple times it started over where it would just start from the nearest position on the track. So we're going to stop this and we're going to run it again, and you can see when it's crashed. So to see when it crashes by starting at the original starting spot, we're going to select 2 this time, we're going to go 5 again, and we're going to let it run. And we can see that the target moves back to the start each time it hits one of the barriers in this training of the model. And you can see the X does get to the finish line in some instances to show that it does finish. So the other Python file we have is labeled Q-learning. This contains our Q-learning and SAR-SA algorithms. It's set up similarly to the value iteration. Again, you're going to change your file name and this track to reflect which track you're interested in. There's also a variable called SAR-SA. If you set it to true, you'll be running this for the SAR-SA algorithm. If you set it to false, you'll be running this program for the Q-learning algorithm. You can see the implementation of these 2 different algorithms because they are similar, but simply a change in the update function in the Q-learning function, where depending on what the value of the SAR-SA variable is, will determine which update function we're going to use. As you can see, we have some print statements to show us how it is updating. So here's an example of one that ran. We can see how it's been updating the Q values. This particular one's for Q-learning. The output looks very similar for SAR-SA. You can see our velocity, our acceleration, and what our new Q value is at this location in the Q table. So this is for this particular iteration, 246,686, and you can see it keeps going through the other iterations as well. So for running each of the functions, your input is the provided text files for the different racetracks. Your output would look something like this. So this is value iteration. You can see each of your iteration stats. So this might be what one of the summary statistics files looks like. Tells you which track, which crash scenario you're running, the number of training iterations at this particular point, and the average number of steps before finding the finish line. Additionally, there's a trace file that's going to give your triplet or your triplets for how you're moving through the racetrack so your velocity and what coordinate you end up at on the racetrack.